we have a little talk here on charts, and these are ones that are commonly available now, and a very brief overview of catalogs. So the reason I know about charts is because I've been using them since, the mid 80s. And I'll talk a little more about that in a moment. And then with catalogs, there are a couple of well-known ones that I learned about very early in my observing. And I've learned a lot more over recent years because of my work with software. I have had to learn about catalogs and which ones are very unique and those that are commonly used. So that's why I know about charts and catalogs. So to catalogs, first of all, some are very old and well known. Some have been around a few hundred years. I would almost characterize those more as lists of objects because to me, the modern understanding of a catalog is a list of information that's been put together by some scientists who are studying some facet of astronomy. So they collect a list of objects that suit their research, and they'll publish something, a paper, and then the list of objects will go with that published paper. So if you were to go to a clearinghouse of such objects like SIMBAD, you would find out that there are some catalog acronyms that are very commonly used. And that is because the International Astronomical Union decides what name shall be used for a catalog, a prefix or an acronym or a mnemonic, whatever you want to call it. And for example, the three letters NGC, they are recognized by the IAU as meaning the new general catalog. Catalogs are coming out all the time because scientists are studying all the time. And like I say, they will generally appear in a peer-reviewed publication. And then they'll be inserted into some of these large online databases that contain professionally peer-reviewed data. And of these catalogs, some of the more popular are, you've probably seen the capital M, which would stand for Messier. And Charles Messier was a Frenchman who worked from, I guess, 1800, give or take. He was kind of unique in that he was looking for comets. So he created a list of things that he kept seeing that were not comets, and those are our Messier objects. So his original list has changed a little bit since the beginning, but now we pretty much agree that there are 110 objects in the Messier list. And most amateurs start out by trying to see those objects in the Messier list. They are deep sky objects. There are a few that are star collections, a double star or a little collection of stars. But mostly they're recognized deep sky objects. Another one you'll run into commonly is NGC, which I just mentioned a moment ago. That's the new general catalog. The funny thing about the new general catalog is it's over 100 years old. The NGC and the IC, the index catalog, were both put together in observations over the years, mostly by Sir William Herschel. He worked with his sister Caroline, and they worked in various places in the UK, observing different things and writing down what they had seen. Now, when they did these observations, they didn't give them an NGC number like you see now. They would describe the object as the thing I saw in sweep number something or another on this night. And historians have gone back and figured out what he meant and how that maps to our current NGC catalog. So the Herschels and son John over the years, they came up with quite a few observed objects. In the latter part of the 1800s, J.L.E. Dreyer gathered together all of these observations and came up with the NGC catalog and the IC catalog. Now, Dreyer, he was a Danish fellow who worked in Ireland, I think, with the Lord Rosse telescope. So that was his connection into astronomy. He later worked with the Royal Astronomical Society history. And so he was in a uniquely good position to gather historical information about these objects, the observations made by the Herschels, and assemble the NGC and the IC catalogs. So there have been some changes to the NGC and the IC over the years. There's a gentleman in Germany named Wolfgang Steinecke, and he did his PhD dissertation on the NGC, and he's done historical research. He publishes his data online now, and he updates it usually a couple of times a year, but he didn't do it last year. And generally the updates these days are very minor, but that's probably the most accurate version of NGC out there. There are many, many specialty deep sky catalogs around these days. If you have one you want to ask about, please do. But the catalogs that are predominantly used for galaxy data are the PGC, which is the Principal Galaxy Catalog. And that also goes by the acronym LIDA, which is a database in France that has put all this information online. Along with PGC, we have UGC, which is the Uppsala Galaxy Catalog. Those both have been around for years. And when I say years, I probably mean certainly less than 50, a few decades. You'll notice as I move down the list here that we're having some of these specialty catalogs that gather together a certain type of object, and that is common these days. The second bullet point I have are the planetary nebulae catalogs. The PK catalog, which you probably have seen, that's a little older. The PNG catalog is a newer collection. Then if you want to think about bright nebulae, there are many, many catalogs. Some of our astrophotographers might comment on this one, but the SH2, which is Sharpless 2, CED, which is Cedarblad, and LBN are popular collections. LBN is Lens Bright Nebulae. Moving on to dark nebulae, which is looking for something that isn't, that just amuses the dickens out of me. But the Bernard catalog, you'll often see B, but the IAU doesn't like single letter catalog mnemonics, so they want you to use BARN, whatever. The Bernard nebulae and the LDN dark nebulae, which again is Lens dark nebulae. Both are good collections of dark nebulae. When we get to globular clusters and open clusters, there are plenty out there. The mnemonic that one might use for globulars is not real set in stone. Most of the globular clusters live in another catalog and are known by the other catalog name. But there is a catalog for globulars that is maintained by a scientist at McMaster's University in Canada. He does a lot of research on the content, the chemical content of the stars and how far the clusters are from us. He doesn't publish any kind of a catalog name and number. But that data is out there and it is actively researched at this time. A similar kind of thing goes on with open clusters, where there's not a list with numbers, but there are cross references to other names that seem more familiar, like NGC. And that is an active point of research, studying open clusters, their chemical composition, and their distance from us, and their movement, and so forth. And there are many, many more specialty deep sky catalogs. If you got deeply into catalogs, you would begin to learn those. But I think for most people starting out, this is a very good list of the ones that are in greatest use. So the next thing is the common star catalogs. Let's start with the SAO, which is the Smithsonian Astrophysical Observatory. Now, that data is a little long in the tooth. It's been out for nearly 50 years, or yeah, 50 years. But I think a lot of go-to and mount controller type software has SAO star information. So I bring that up for that very reason. The SAO catalog wasn't that big. It's a little old, but SAO star numbers are in common use. Pardon me. Another is the Hipparcos catalog. You remember in the late 90s, we had the Hipparcos mission and the Tycho mission, which gave us unprecedented accuracy of the motions of the stars and so on. So you'll find catalogs that list Hipparcos numbers, HIP. You may even see XIP, which is the extended Hipparcos data, which is just a revision with more modern data. It's essentially the same data set. And the one you've probably read about that's going on now is Gaia. The Gaia mission is a satellite that's taking a lot of pictures of a lot of stars. And as the data is received and mushed, they release dumps of all this Gaia star data. It's an enormous amount of data, and it is an ongoing project. And as the others, there are many, many other star catalogs, many. There are some specialty catalogs that you should know about.
Phyllis, there's a question. We didn't talk about this. Do you have chat open?
I do. Tycho, someone asked about Tycho. You know, it's not so much that it's falling out of favor as the data is becoming a little outdated. So I think Tycho was proper motion data, if I remember correctly. And the thing is, the Gaia catalog, can you go backwards? No. The Gaia catalog has much more accurate data and a heck of a lot more of it. So it is supplanting the Tycho data. Does that answer the question? Yeah. Yes, thank you. Okay. All right, on to specialty star catalogs. Washington double star data, WDS. This has been an ongoing study for many years by the Naval Observatory. The data is updated continuously. I don't think it's updated every day, but it's pretty doggone often. If you are seriously into double star observing, you will find in that double star catalog most of the doubles that you can see. You'll find in there magnitude data for component stars. You'll find separation of component stars. You'll find spectral data. You'll find all kinds of great stuff. And if you want to get into double stars, you really should take a look at that catalog. Another lot of stars that people become interested in is variable stars. And the general catalog of variable stars contains variable star data. It's updated not continuously, but every few years. And the data will include things like the magnitude range of the variable star and how long it takes to go from a minimum and a maximum. What type of double it is, because they show different characteristics. So if you want to really learn about variable stars, you probably want to look at the GCVS. Now, the AAVSO is an umbrella organization in the United States, the American Association of Variable Star Observers, I think. Of course, there are members of the AAVSO from all over the world. If you become a variable star observer, you will learn about the AAVSO. You will learn about contributing your observations to them, and they keep a database of all this stuff that anybody can access. It's called VSX, which is the Variable Star Index. So that's an online service. It's not really a printed catalog because it changes all the time. And the last specialty star catalog I would bring up is the catalog of galactic carbon stars. Now that catalog's getting a little bit old. There's the only listing I know of that gives us carbon star information. Carbon stars are cool because they're very red and they have physics in them. You can help me out here, Steve. The physics in a carbon star is such that it is different from a common red star in the galaxy. They are end of life. I think they were high mass and maybe aren't so high mass anymore. The bottom line is they're a load of fun to look at. And there are a few of those that I'll look at once a year whenever they're coming around. Heinz Crimson Star is one that comes to mind. It's in Lepus. Herschel's Garnet Star is one, and I can't remember where it is in the sky. But carbon stars are cool, and if you're interested, you can go find the carbon star catalog. And it would be cool if my clicker would click. Okay. This is really an important slide. There's a lot of information on it. If you already know these things, please bear with us. If you don't know these things, this is probably the secret sauce for tonight's talk. And that is how to figure out what your field of view is when you're observing, because you need to know that. If you want to look at a chart, a map, the map will have on it some kind of a grid or some tick marks or something that will show you how much distance in the sky is covered by the chart, the scale of the chart. And if you want to learn how to interpret the chart as you look at it and correlate that to what you're seeing in your eyepiece, then you need to figure out the field of view of your telescope and eyepiece. That's a thing that is a system. So the field of view of your optics are a combination of the magnification that the eyepiece gives in the telescope, any Barlows you might be using, all that. And that is divided into the apparent field of the eyepiece. So, okay, we have an eyepiece. And generally the eyepiece will have on it the focal length of the eyepiece. You can usually find the apparent field of the eyepiece in advertising literature. Let's suppose that you go and you buy yourself a nice new Meade eyepiece. Well, it'll probably say, this is the latest and greatest 100-degree eyepiece. The 100-degree eyepiece means the apparent field of the eyepiece. Some of orthoscopic eyepieces are 45 to 50, plus a eyepiece is around 50. Some of the wider field things like, I use something called a wide field that was produced by Teleview many years ago. It's a 65 to 68 degree eyepiece. Then you get into the corrected eyepieces for the faster telescopes. Maybe they're 82 degrees like the Naglers, or maybe they're 100 degrees or 110 degrees like some of the Ethos eyepieces. All of that 100 degree, 82 degree business is the apparent field of view of the eyepiece. I think you probably know what the focal length of the eyepiece is. Printed on the side of the eyepiece will be 32 millimeters or something like that, 7 millimeters. That is the focal length of the eyepiece. So the next piece of the puzzle is, what is the focal length of my telescope? Well, when you buy a telescope, it probably says the focal length. If it doesn't, you can figure it out. You can measure the aperture of the lens or mirror, or it's in the sales literature. Multiply that by the focal ratio, which should be in the sales literature. There are ways to figure all this out with a tape measure, but I don't think I want to go into that tonight. Figure out telescope focal length, figure out your eyepiece focal length and focal ratio and apparent field. Now, the next thing you probably need to know, and hopefully you do know this with your telescopes, you know what the magnification produced by a telescope and eyepiece combination. It's the telescope focal length divided by the eyepiece focal length. And let's go back to physics class in high school. We have to use the same units of measure. Don't say an 8-inch telescope and a 32 millimeter eyepiece. That won't work. Let's all work in millimeters or inches if you have to, but millimeters is easier. If you use a Barlow lens, then you just magnify the multiplication, the magnification by the Barlow magnification, and that'll give you the total magnification of your optical system. Okay? So then for our true field of view, how much sky we actually see through the eyepiece and the Barlow and the telescope. The true field is the eyepiece apparent field divided by the magnification. So for example, I know that my 8-inch telescope, which is an f7.6, and my favorite 24 millimeter eyepiece and no Barlow, all of that will give me a 1 degree field. I just know that. You probably are going to want to know the field of view of your finder scope. Hopefully that's in the sales literature. Otherwise, you're probably going to have to measure that. It can be done out under the sky, but I would prefer not to go into that now. I happen to know that the finder scope on my 8-inch telescope gives a 3 degree field of view. These are just things I know. And by the way, I don't remember all this stuff just because I have photographic memory. I made a little spreadsheet many years ago, and I plug in eyepieces and Barlows and things, and I make a little card, and the card gets laminated and taped to the side of my telescope. And that's where it always is, and I never lose it. So anytime I want to look at a very high power, let's say, a high power view of something, then I can look and see exactly what the true field of view that eyepiece in my telescope with a Barlow, what that's going to be. I can't remember all this stuff, so I write it down and I put it in the eyepiece box or actually on the side of my telescope. I highly recommend this. So I just want to mention this. I think Planetarium software would be a very, very good topic for another class. It isn't the focus of this talk, but there are some really good ones out there. If I don't mention the one that you like the most, please don't feel offended. I use mostly desktop software. I have used Sky Safari on an iPad and on my phone. Sky Safari works really well. I can tell you there's a new version in beta test right now. It's going to be called version 7. It will come out on the iPhone and the iPad first. And it'll probably take them a few months to get the Android version ready. But it's in the works, and I really expect it any day now. On the Mac and Windows side, which is what I use a little bit more, I'm more familiar with that. In the good old days, we used the Sky around here, and it has evolved greatly over the years. Software Bisque makes that one, and it is now almost required if you use a Bisque mount, the Mighty or the Paramount. Those are really nice mounts. The Sky is built to work with those mounts. And we may have moved on from the Sky because we're using the Sky 6 around here. And Mark could probably tell me, but we've had that a long time. So we've tried a newer version, the Sky X, and it wasn't as pretty as I wanted it to be. I'll just be frank, it wasn't that pretty. The Bisques have now released the Sky 64, which is a 64-bit version. It works fine as far as I can tell. I haven't had any problems with it. It is out maybe as an experimental version. They are going to move to the Sky 64. And as far as I can tell at the moment, it's in good shape. So if you have a Bisque mount, you probably already know about the Sky. More recently, we've become more used to Stellarium, which runs on Windows and Mac. It's free. It's very attractive. It will do just about anything you want it to do if you can decode the hotkeys. So having moved from the Sky 6 to Stellarium, Mark found, he found something in the help file that was a listing of all the hotkeys, the functions and the keystrokes required. And that was a game changer for him. Now he can do just about anything in Stellarium he wants to do because he's got the hotkey list there and he knows how to make it happen. Stellarium is an open source free software. So I can't find it in my heart to be mad at the documentation. But that hotkey list is really helpful. CartUCL is an older planetarium program. It is also free. And you can extend the data in CartUCL. I think a lot of people like that feature. It isn't as pretty as Stellarium is, but a lot of people have used it for a long time and are very, very comfortable with it. It's free. And the last one I'll mention is Starry Night. It's a very attractive planetarium. It's got some bugs that bother me. It hasn't been updated quite as much as Stellarium has. It is a pay planetarium program. So there are plenty of people who swear by it, and there are some people that are mad at it for the bugs. But you can certainly buy that and try it if you like. It's Mac or Windows. And it's probably due to be updated sometime in the not so distant future. I'm not aware that they're working on an update now. It should be mentioned that Sky Safari and Starry Night are produced by the same company. So it could be that the push is on for Sky Safari at the moment and Starry Night will come next. So if you want to know more about planetarium software, maybe you can post to the RAC Academy list. so that we'll know what to prepare for another class in the future. Okay, so charts, the meat of the talk. Usually the charts we see these days will say something about J2000 on them. And that's because when the chart was plotted, the data for the stars and the deep sky objects were referred to the epoch J2000. That means they were accurate in the sky as of January 1st, 2000. Do they move? Yes, they do. They meaning the stars. But I don't think you would find it noticeable for the most part. I would expect for new charts to be printed for the year 2050, but I really don't think you would see that until 2035 maybe. So if you want to buy some J2000 charts now, I would urge you to do that. They'll be accurate for many years to come. Another thing to look for in the star charts that you choose, they should be dew resistant. Either they're coated paper or they're laminated, one or the other. My very first set of charts were Sky Atlas 2000 and they were just paper. They weren't coated, they weren't laminated, and they didn't last very long. They just sort of came apart. I replaced them with laminated charts and I still use them to this day. That's probably been 30 years. So I urge you to check whether the charts are dew resistant. Now, how do the charts look? Well, sometimes you have white stars on a black background or black stars on a white background. You can certainly use either one. You might like to try either one with a red light to see which one is easiest for you to see. I can tell you that my laminated Sky Atlas 2000 is white stars on black background, and that was perfect for years. I did notice that the red flashlight produces a little bit of a glare on that laminate. All of the other charts I use are black stars on white, and it's more of a coated paper rather than lamination. And so a red light doesn't bother me on any of those. So it could just be a function of laminate. At any rate, they come both ways. You can look for them either way. The last thing about charts is that you probably want to use those to star hop. That's probably the whole reason you're listening. I will go into more depth with a demo at the end of the talk. But the most important things, you've got to learn the field of view of your equipment. And you need to know the field of view depicted on your charts. It's the only way you're going to be able to figure out how far to move to get to another star. You also are going to have to know what your telescope optics are doing to the view. This is a big thing. If you have a Dobsonian, the view is going to be left, right, reversed because of what mirrors do to images. If you have a refractor, it's probably going to be left, right, reversed, and inverted up and down because there's a combination of mirrors and lenses in that view path. So you very definitely should learn which one you've got. A little experimentation in the front yard will probably work for you on this. So one place to find charts is the monthly insert in a lot of astronomy magazines. So the US magazines that you're going to find in a bookstore, or I've even seen them in grocery store magazine racks. The two US magazines are Astronomy and Sky and Telescope. Both of those come out monthly, have a depiction of the night sky in the centerfold on a monthly chart. The UK magazines Astronomy Now and Sky at Night are also monthlies, and they also have charts. The Canadian magazine Sky News is bi-monthly, so I'm guessing the charts in those are bi-monthly. accurate for every 2 months. I don't know that. I have looked at Sky News, but it's been some years. So there are plenty of magazines to check out at your local bookstore. This is a photo that I took of the November issue of Sky and Telescope, arrived the other day. So this will give you an idea of what one of these center charts looks like in a magazine. And yeah, can you see my cursor? Yeah. If you rotate the magazine so that you are facing west and this part of the picture is up against your chest, this is really how the sky will look to you if you're facing west. And so on as you move around the horizon. If you crane your neck and look up, you're going to begin to see these things. Now, this chart is good for 40 degrees north latitude as far as I remember. And I'm sure it's printed on here somewhere, but I don't know where. And the time when the picture is accurate, okay? So for tonight, late October, this picture would be accurate at about 10 p.m. 40 degrees latitude is a little north of where we live, but it's not enough to matter. We live at close to 36 north. This is just fine for us. So this happens to be a Sky and Telescope that I had on hand. Another place where you can find charts is the good old Planisphere. And that is very similar to the chart in the middle of the magazine that we just saw, because it depicts the whole sky. And it depicts it from a certain latitude, which is often 30 or 40 degrees. And they work great for our latitude. You can find these at bookstores. I looked around this afternoon online and I noticed that both Sky and Telescope online store and Astronomy online store have planispheres. You can also shop for them on Amazon if you want to. They're very useful for learning the night sky. This is a picture of Mark's very ancient planisphere. I have it turned so that you can just see Orion. Can you see my cursor? That looked like a yes. If you look here for Orion, it'll be coming up, thank you. It'll be coming up in the east in what, around early December, I guess. So I usually associate Orion with going out to check the mail around Christmas time in the evening. It's coming up in the east, and Orion is lying on his side. And these stars, the belt stars, look like they're vertical. And you'll notice that if you look with your eyes, Orion looks kind of big at the horizon. And when you have the entire sky depicted on a piece of paper like this, they depict Orion as being rather small. So this is something you have to learn. You have to learn the scale of your chart as it compares to what you see in the eyepiece and what you see in the sky. So I'm afraid there's no getting around it, folks. You need to learn your constellations. It's just the way it is. If you knew the constellation of Orion looked like this, you would look at this chart and go, oh, I know what that is. Or Auriga, that's another good one. That's easy to identify. And so on. So there's a planisphere. This planisphere is over 40 years old and it still works. It's great. Now some actual charts that are very commonly used these days. The Pocket Sky Atlas, published by Sky and Telescope, I think. There is the original small version. There is the new, yes, thank you, Mike. And there is the jumbo version. It's very nicely bound. It's bound so that you can lay it flat. It's comb bound. Exactly. And it is coated paper. So when I have had my copy out, when I've had my copy out in, let's say, a very dewy August, lying in a chair, doing binocular observing, it holds up to the moisture very well. It really does. I tend to use my copy with binoculars. They're really handy to use with small telescopes. And the most wonderful thing is it's so portable and easy to deal with. So this is a picture of the Orion region shown in Pocket Sky Atlas. So there's a couple of things you can see here. You can see this usual belt of stars. That's easy. You can see Rigel down here. That's a foot. Betelgeuse is up here. The thing you should notice is the scale of this map. You can tell just by looking at this page. You can see a hash mark. You can see 6 hash marks. So we know that 60 arc minutes divided by 6 hash marks is 10 arc minutes. Yeah, whatever. 10 arc minutes. So we know that this is 10 arc minutes. I said that wrong. 10 minutes of right ascension. Thank you. Okay. And if we look over here at the declination sign, we're seeing a tick mark, 10 of them between 0 and -10. So we know this is 1 arc minute. So now we know that we can see 1 arc minute. And it turns out to be about 10 minutes of right ascension. Once you know how that measures up in your field of view, you know how to jump from, let's say, this star down to here. You know how many field of view widths you have to move. So that's with the Pocket Sky Atlas. This is going to be the largest scale one that I cover. And again, it's terrific. It's a very handy chart. The one I tend to use most now is the Interstellarium Deep Sky Atlas. This is the newest of the ones I'm going to show you. And somebody's got their hand up.
Yeah, sorry, Phyllis. I was wanted to highlight on the Pocket Sky Atlas.
Yes.
If you go back one page, if you look towards, if folks look off to the kind of the left-hand margin, you'll see kind of these red circles. So that gives you a 4 degree, 2 degree, and ½ a degree kind of bullseye, which happens to be the exact measurements if you use a TELRAD, which is a 0 power or kind of a illuminated, red dot finder. So you can actually, use that on your chart, look it up on the sky, and that's a really easy, simple way to measure angular distances in the sky.
Absolutely. Here again, you have to know the field of view of your equipment and your chart. Okay, so back to Interstellarium. It's the latest printed atlas I know of. It is deeper. It has star magnitudes down to 9.5. And it is nicely bound. It lies flat and the paper is coated. So it holds up to dew pretty well. These are commonly available in the United States now. They were originally printed in Germany, and it took them a little while to be translated to English and come over to America, but they're around now. You can get those. And here is a picture of the Orion region as depicted in Interstellarium Deep Sky Atlas. You can see that we have a degree, and I can't remember how much right ascension is depicted here, but it will be shown across the top of the page, and you'll be able to understand what one grid box covers, how much distance is covered there. I'm guessing it's about a square degree. So once again, my eyepiece and telescope combination I told you about a while ago was 1 degree. So it looks like it would be 1, 2, maybe 3 star hops to get to M42 from this bright belt star. These are excellent charts. I really like them. Something peculiar about this particular chart is they they show things in different fonts according to how likely it is that you would see them in different telescope sizes. So I think McNeil's Nebula is in light gray. It's harder to see. You're going to need a bigger telescope to find it. And then something like M78 is rather bright. You can see it in a small telescope. So they're using different fonts to show how likely a thing is for you to see. I really like that feature. And now the one that I'm going to do a demo on is Sky Atlas 2000. I've got the laminated version, but I also have the unlaminated version. It shows stars down to magnitude 8.5, which to me was the sweet spot when I first started observing with a C8. Mike,
Yep.
would you like to conduct a drawing?
I would. So for anyone who is actually in this meeting, we have it is a used version, but don't think it's ever been in the field, and it has never been marked on at all. And this was donated to the club along with recent equipment, and we'd like to have this as a door prize. So if you would like to be considered for the door prize, if in the chat you could just enter in your name and then the word chart, so we know which names to select, or in case you put another comment in there, we'll put that in for a drawing, and we'll do that after the demo.
Okay, perfect. Thank you very much, Mike. So again, Sky Atlas 2000 is one I've used for 30 years or more. I really like it. Okay, so here is a photograph of the Orion region as shown in Sky Atlas 2000. Now, this version that I have is the same one that Mike showed us a while ago. It's the indoor version, meaning it's paper and each chart is folded in half, and it all comes in a bound book. Very handy to deal with. The other version that I have is laminated sheets of paper in a box. So the scale is the same, but it's a whole different deal when you're carrying a book as opposed to carrying a little box of coded charts. Those coded charts really like to blow around in the wind, I can tell you that. That's what the little spring clip is for. At any rate, here you can see that the scale here is finer than we had in the Pocket Sky Atlas. We have 1, 2, 3, 4 hash marks across 20 minutes of right ascension. So I guess these are 5 minutes of right ascension wide. And we have 1 degree marks across here. So here again, you can pretty well decide what the scale of the chart is, and you can correlate that to your field of view. You'll also learn as you use these charts, you'll begin to know when you see the size of these stars, you'll see Betelgeuse as a great big black star, and you'll think, gee, I can see that one pretty easy, even in the finder scope. And you get over to these real teeny tiny guys, and you may see those and you may not. So this is a learning thing you'll have to do with your charts and your telescope. There may be more shown than you see or not. So, and the last one I want to talk about is one that's been around for many years, but it's not available right now. It's Uranometria 2000. This was published by Wilman Bell Company up in Richmond, Virginia. They retired, and they have just sold all their holdings to the American Astronomical Society. And the AAS says that they're gonna start offering Wilman Bell publications by the end of October. I checked this afternoon, and they aren't up there yet. So this is a very popular Atlas set, so I really believe they will be reprinted and offered. but they don't seem to be out there quite yet. The drawback I have with these is a 2-volume set, or at least the old ones that I have are 2 volumes. I believe there's a 1-volume second edition that's available now, or will be. It plots stars down to 9.75 magnitude. The pages, yeah, that's what I've got. The pages are uncoded. So if you leave that book open on a table out while you're observing, those pages are going to get wet. You should lay something over them or use them only indoors, whichever. I have done both of the above. This is a photo of the Orion page in the Uranometria 2000. You can see the belt stars. Look how big they look on this picture as opposed to that Pocket Sky Atlas picture. The scale is much finer here. And you can see how much real estate is covered by a degree. And then we can see that the vertical grid is 2 minutes of right ascension. So this is kind of maybe a more advanced observer can find use for this. I never did. I know there are many, many observers who swear by it. So I think it's just what you get used to, really. They're all excellent publications. And I'm really hoping that the AAS will re-release the Uranometria 2000. Whatever. Okay, so I think, yeah. I'm going to get ready for the star hopping demo with a chart here in a moment, and I'm going to have to rearrange some things on my desk. The first thing you've got to do is learn a little bit about the constellations in the sky. If we have demand for a constellation session out under the stars at some point, please request it. Maybe some of the more experienced observers can help out. At many of our public observing sessions, I'll go out with a laser pointer and point out some constellations, and people generally like that a lot. We'll see whether you need that or not. The second thing is the scale of your chart. Well, we've been talking about that. We've been talking about the field of view of your optical system. So once you can put all that together in your mind, some people find it helpful to make a little template that is the scale of their astronomical charts and depicts what can be seen through their eyepiece. So, for example, you might use a little hole punch, or there are clear plastic overlays that come with some star charts that will show you the field of view. So something along those lines, that's a do-it-yourself thing you can do for yourself if you need it. I won't be using that in my star hopping demo. I'll be using a pencil. So with that, does anybody have any questions you want to fire off before I turn on my webcam? No? Okay. Maybe. My template, yes, you'll see an example of it. I will show it to you. You will laugh, I promise. All right, let's see. I guess what I'll do is I will cut off my screen share and I will go away for a moment and I'll come back on when I'm ready. Mike, if you want to take care of the prize draw while I'm fiddling around, that'll be good.
Yeah, I just want to make sure if no one else has, I've got 14 people who put their name in. So if there's anyone else to go ahead and do that, I'll give it just another second or two. And if we don't have anybody else. All right, and okay. Oh, Steve, hold on, let me add Jen here. I'll do another random Okay, it is Dave, Dave Filipowski. So congratulations. I will, if you want to drop me your email or whatever, I'll make sure we get that out to you.
And I'm just floored. Thank you. That's wonderful.
Now, if you want, I'll let this. If we have this one, the Ultra, or no, sorry, the Uranometria 2000 or the Sky Atlas 2000. So Phyllis covered both, and we've got both. In fact, we'll be doing more giveaways in the future of stuff that's been donated. So take your pick. I think I like this one better, but it's totally up to you.
Atlas, take the Sky Atlas.
So Sky Atlas, Dave, or
Oh, the Sky Atlas.
okay, perfect. All right. So everyone, keep an eye out for this one coming in in the upcoming meeting.
I truly am thrilled. I cannot tell you. I know a lot about that sky chart, and it's awesome.
Yeah. Well, like I said, it was donated, and I can tell you, it has never been outside. It is in wonderful, wonderful condition. So, not a bend or a page, earmarked or anything. So
Yeah. I have an old one from college that's not that one, but I have an old one from college. It's about 4 by 5.
Yeah.
Be a lot easier to see on that one.
Yes. I also posted in the chart, or sorry, in the chat. Phyllis mentioned planispheres, and I put a link into that. At least my favorite one. It's a big 16-inch. It's laminated with some plastic as the front cover, and it lasted an incredibly long time. With I don't know how many. I used to bring it out to all kinds of events, and kids would use it as a frisbee, and it lasted a very, very long time. But it was nice and big and easy to read. So
Okay. So are we ready to give this? I wish you people could see this contraption I have on my desk to show you these atlases. You would be amused. I will share my screen, and hopefully we will see my camera. It's not as well focused as I might hope. Can you see it?
Yeah, it's showing up, but it is a little out of focus.
Well,
Can you back away from it just a little bit?
how about that?
Yeah, that's a little better. Well, a little.
You know what? It's picking up this penny.
Yeah.
I didn't do this without the penny. I've put the penny down to give you a sense of scale. I don't know if that did any good or not. I don't know. I'm tempted to go right ahead and keep on keeping on. Yeah, that's a bad thing. I shouldn't have done that. Okay, there we are. I don't think it can focus any better than that. It certainly looked crisper yesterday. Okay, so back in the good old days, I was very new to observing. I had a new C8 telescope, and the astronomy club that I had just joined decided they were going to have a Messier marathon. So I was excited, and I got some things together, lots of coffee and blankets and charts and things, and I went out with my C8. And I knew that there were 100 objects, or 110 rather, that needed to be viewed. Well, I didn't know how to star hop that night, but I learned that night, because once you get into the Virgo galaxies, you better know how to star hop. At any rate, I don't know whether it's easy to learn to star hop or whether you just have to learn it. I don't know which. But here's a little bit of how it went for me. I look at the belt stars of Orion here. And I think they're about a degree apart. I just happen to know that. I could fool around with the chart and figure that out, but they're about a degree apart. They're bright stars. It's a peculiar sort of pattern, and you can learn to find the belt stars of Orion rather easily. So back in those days, I used a very sophisticated template to depict my eyepiece field of view, Doug. I hope you're listening. This is my template that I used. I used my pinky because I knew that it was about a degree and about the width of my little fingernail was about a degree. And so, using this metric, this is what I did. Pardon me. So, I learned two things actually. I learned that if I use my finger on my chart, I could step about 3.5 steps. And so I knew that my eyepiece field of view was about a degree. So I was using a C8, which is part reflector, part refractor. And things were backwards. I knew that. So I figured out what this looked like in my eyepiece. And things were flipped backwards. So I had to make that little translation in my mind to figure out which way to push the telescope to go this way. Okay. Once I figured that out, I knew, okay, since my field of view is about a degree, then I can look very carefully in the eyepiece. And I could see this, and I would move the field of view so that this was at the top of the field of view. And then I moved a little further and I could see this star. And I nudged it a little more and I got to where I could see this. And another little nudge, and there it was, M42, which is what I was looking for. So I had to learn about what my optics were doing to what I was seeing. I had to learn about that flip thing. I have since learned that mirror reverse step, which I still have in my telescope, is a real booger at about 2 in the morning because my brain just gets too tired to do it. But that's the way it is, and that's what I live with. The second thing I had to know was if I had my widest field eyepiece, it's a lot easier to correlate this stuff to the eyepiece field of view because these big stars are bright. They're going to show up in my lowest power eyepiece. And my lowest power eyepiece gives the biggest slice of pie, so to speak. If I put a high power eyepiece, which has a smaller field of view on this star, it's going to be very, very easy to get lost in a 3-degree star hop. First of all, I'm using a Dobsonian, so the sky is moving. I have no motor to counteract the motion of the sky. So that's hard. The tiny field of view is hard. And if you get a little off track with a tiny field of view eyepiece, you could be over here somewhere and not really know how to get back to over here because there's not that many stars in the field of view. So I strongly encourage you to learn how to do your star hopping using your widest field of view eyepiece. That's the longest focal length eyepiece that you have. No Barlow, just an eyepiece. And just because somebody told you when you were a little kid, how much magnification does your telescope have? Well, mine has more. High magnification is not what you're looking for here. It has its place, but really, low magnification, wide field is what you need for this part of learning the sky. Really the best thing to do. So that's how I do it. And that's how I did it way back when. Now, there have been other times when I was looking at something really small, something really hard to find. And in those cases, I would use a larger scale map than this one. I would use that uranometria chart that I showed a while ago. It shows dimmer stars. They're easier to follow along to get to a very dim thing that's hard to find. There was nothing, I'm talking here of P's 1. This is a planetary nebula that is inside M15, the globular cluster. It is really hard to find. And in order to star hop around a globular cluster, which is a complete hairball of stars, I needed more magnification and a better map. And it was easy to get lost. I bet I spent over an hour trying to find that thing, but I did find it. So there you have it. Different charts for different telescopes, different applications, different ends of the hobby. You're just starting out and you're just using binoculars, the pocket sky atlas can't be beat. If you're going to a very, very dark sky with a bigger telescope, you're probably going to want something more. So does anyone have questions? I see we have a couple. Yeah. Any questions? Is everybody ready to go star hopping?
So I have a question, Phyllis.
Yes. Yes.
So one thing I've always wondered about, and Mike and I have actually had a couple discussions about this. So let's see, we get the right ascension declination of Orion. Let's say we don't have a star chart. We're trying to find it. Say the right ascension declination of the Orion Nebula. That
Yeah.
right ascension and that declination was something that's actually chosen, I think, at really at one of the equinoxes, right? And so it actually does change a little bit over the year, but what's published in the on a star chart is where it's at on one particular night out of the year. So how do we?
Not exactly.
Okay,
Not exactly.
So that's my confusion. That's why I wanted to kind of get your thought on that. How would we go about actually finding, let's say where it was, let's say I had a setting circle and I do on my meet, and I want to, I know it's not going to be at a particular at the published right ascension declination. It's going to be slightly off of that, right?
Well, that's
On
a
any given
question
night.
about to what epoch are your coordinates referred. In other words, the picture on this chart is accurate as of January the 1st, 2000.
Mm-hmm.
Now, certain stars don't move very much over 20 years, and others do. This chart will not capture the ones that have high proper motion.
Mhm.
They will change a little bit, and that's why you reprint star charts for another epoch.
Mm-hmm. Mm-hmm.
So the night of the year, let's say that you want to look at this several nights during the year.
Yeah.
They're not going to change noticeably over a year's time. In other words, if you look in December, the picture should be just about the same as March.
Mm-hmm.
It really should be. The planets, of course, move differently. They move a lot
Yeah,
faster,
sure,
so
sure.
they do appear to move.
Yeah.
And then I would imagine that if you're trying to, let's say, replicate something, you probably have enough mechanical errors or manufacturing kind of errors just in the mount itself that it'll always be off no matter what by a small margin, especially if you're on a software BISC mount, but it will never be 100% correct.
So I'm getting an argument inside my head that says right ascension never changes. It's the declination that changes
Declination
based
does.
on the seasons. So
Yeah.
left to right will never be any different. It'll always be the same based on whatever hour it's asking for. It's the declination that changes because the earth wobbles for seasons. Is that correct?
That's not correct.
Okay, so tell me, that's why I'm trying to understand what y'all are saying there.
Yeah, that was kind of my
I'm
argument. Mike and
confused
I
by it.
were arguing, or not arguing, but we were talking about the same thing.
Yeah, I'm trying to reason out what you're saying. I'm lost.
I think you're talking more about how the ecliptic moves in the sky over a year's time. But right ascension and declination are regardless of that.
Okay. They're absolute to the
Yeah.
sky.
They're chosen
Yep.
randomly to be a certain point in the sky. That's where you start counting from.
Right.
Oh, so
And-
that's kind of the whole idea about the crystalline sphere of the
Yeah.
of the stars. What is that? What 30? Is that 1 parsec out from the Earth or something like that? Or but there's
Say that
something
again?
like that. Is it 1 parsec away from the Earth that that we go out with the sort of the sphere, the navigational sphere of the Earth?
Yeah, I don't know that.
But it's
But-
well outside well outside the Earth, and that's why it's completely fixed in the sky at that point all the time. It's the ecliptic that you're saying is moving.
Yeah.
We're moving around the ecliptic. So
So
Yeah.
the right ascension and declination is reference to the stars, not to the earth.
yeah,
So it's absolute in relation to the stars.
It is. And Steve, if you studied star catalogs that contained high proper motion data, you would see proper motion in RA and in declination.
Yep.
So certain stars will move in both. Some stars hardly move at all.
Yeah, I always
That's why
think
they replot everything every so many decades.
of Mark's Bernard Star project he's done for so many years that shows the proper motion of Bernard
Right.
Star.
And that one in particular is a high proper motion star.
Yeah.
So it does move. What was I gonna say? Dang, it got out. I
So-
was gonna say something, but it got away.
I was going to ask a question, Phyllis, especially for some folks that may not be very familiar with star charts. I see different colors. I might be seeing some different shapes and things. Could you comment on what kind of most charts use to maybe help the reader understand what it is that what does the key look like when you're looking at one of these charts?
Yeah. It turns out that the Sky Atlas charts has a legend across the top of the page that defines these colors.
we actually can't
And
see that. If you could,
Example, this is part of Bernard's Loop, which is an H2 region, as you know. Galaxies are going to show up in pink. There's one. Can we see that? Yeah. I wish this was sharper. Anyway,
Yeah, I don't
that's
think-
a little galaxy.
Yeah, Phyllis, I don't think the key or the legend is
Yeah, the
showing
legend
up.
the legend is off the field of view of our
It is off
of
the
the screen
top.
share.
I'll try, but this is dicey, folks.
Okay.
Yeah, there you go.
all right,
Okay.
there
Yep.
you go.
All right.
Yeah.
Thank you.
Okay.
Push it away from you just a little bit. If I
Guess
read
what?
your arm correctly.
Pushing it away is not what you think.
There you go.
There you
That's
go.
much better.
All right. How's that?
Yeah.
This will
perfect.
also show you some of the different symbols that are used. Let's see, this is a globular cluster symbol. It's a circle with a cross in the middle. The smaller the symbol, the dimmer the object. Just wrote on my book. This is a planetary nebula symbol. And again, the smaller the symbol, the dimmer the object. These are nebulae. And I showed you Bernard's Nebula a moment ago. And then these represent galaxies. The bigger the symbol, the brighter the
So I have a question, Phyllis. There's a
Yep.
little green blob that's, if you come down between the 40M and the 20M, come straight across, you see a
Yeah.
little green blob that looks like a thumb and fingers almost. Yeah.
that
So,
guy.
right. I mean, how do we know what that is? Because it's not labeled.
It's not labeled. I don't know what it is.
Okay.
Some charts will label different things. And there are errors on every set of charts. So, as you learn the sky, you begin to know what that is. I don't know what it is. Something north of Orion. I don't know what it is.
I mean, chances are, if it's a nebula, it may not be naked eye visible, but
Very
you can
definitely
photograph
possible.
it. Yeah.
Right. Right.
I think that was one of my biggest confusions when I first started using the charts. Was I expected to see all these things because they were on the chart.
Oh,
And
yes.
because of the limiting magnitude, you couldn't necessarily see what was on the chart.
No. Especially the deep sky objects. The stars are a little easier because the big black stars are the bright ones, and you're probably going to see those. I will say this: there's one, well, many advantages to using a planetarium program, and you can set the epoch depicted by the planetarium software to right now. You can set it to 2000. You can set it to whatever you want. It's drawing the stars. It knows the arithmetic of how to change the position. So that's what happens. You tell it what epoch. I want to see the way the stars look right now. It'll do it. The chart obviously cannot do that. Another really nice thing is with these planetarium programs, you can tell it, don't draw the stars that I can't see. Limit the dimmest to 8th magnitude. And the chart shows what it shows. It's good to know that it's showing down to magnitude 8.5. But if you're observing in a place where you just can't see 8.5 stars and all you want to see is 8th magnitude stars or brighter, you can usually tell planetarium programs to do that. You can match the view better with your finder scope, or you can have your reason. But I don't want to go too far with planetarium programs because that's a whole topic. And we can get to that later when Mike's
I do want to
ready.
interject,
Right,
though.
Mike?
Yeah.
Hey, so Phils, I do want to say though that what you're teaching us about star hopping also translates over to planetarium programs, because planetarium program is no guarantee that you're going to find the object.
Right.
Your scope, it might control your scope and you might slew your scope directly to an object, but you might not be able to see that object. And the only way you're going to really know that you're on that object is by looking at your star map and hopping around and making sure that the pattern of stars that you see represented are the same ones that you're seeing in your field of view. And
That's
then
right.
once you know you're there, then you can do things, little tricks with averted vision, like thumping the telescope or keeping your eyes closed or using the corner of your eye to try and capture that object. And also too, I will say this, that if you've not seen a particular object type in a while, like if you've never actually observed a globular cluster, it may take your brain a few minutes to actually process that image so that you can see that. So staying and lingering at the eyepiece is really important to give your mind the ability or the chance to process that, and then you just might begin to see it. And I think we saw that a few nights ago when we were with one of our younger members, and he was actually observing a globular cluster for the first time. It took him probably about a good maybe 30 seconds before he actually recognized what that was. He could
Right.
perceive it. So
That is very true.
2 questions in chat, fellas. Rob Parson was asking what what's the Green Islands? I don't know if we answered that well enough.
I
What are the
think he's
green
talking
islands?
about the nebulae, the
Right.
green. That out of there.
Yeah, and then Steve, to your point, that kind of finger and thumb thing,
Mhm.
I looked it up. It's B225. It's a dark nebula.
Okay.
Yeah,
The other question Tony is asking, how to find M31 Andromeda.
Well, you're gonna have to wait. I don't know, maybe it's out there now. Yeah.
Huh?
In order to do that, is it reasonable to ask me to find it? Sure. Now, what are you really asking? Do you want me to show you how to do it on the chart?
I think I heard that was a yes.
Yes.
Oh dear.
I mean, I think what I would say here, Phyllis, is learning the constellations, and there are major objects like the Orion Nebula, Andromeda Galaxy. There are big things that are fairly easy to see. And that's the first thing that any beginner should do is learn Auriga, learn Cassiopeia, learn Orion. And then from there, you start learning the major objects related to those constellations. M31 Andromeda Galaxy is related to Cassiopeia.
Yeah, I'm
Well,
going to say that when I first started myself, you're looking at this, these star charts were, and let me just say, these are great charts. But I found that because I was so unfamiliar with it, I needed something that showed less data. And so
Yep.
I actually used the star charts at the very beginning that were in Night Watch, which actually has a really nice set of general star charts. And they basically they take those, in those charts, they highlight those major night sky objects like M31, the bright ones. And so for me, again, I was just starting out. It was easier for me to use, and the Night Watch star charts are accurate, but they're not as accurate as the ones that Phyllis is showing. And I think Phyllis was trying to actually say this a little bit earlier. A planisphere is less granular, and then some of these, and then the pocket sky atlas is a little more granular. And then you get down to like, the Sky Atlas or some of these others like Uranometria, which are very specific. So you're getting, more and more detail. But for me, I had to have less detail. So I used something like Night Watch, and I used those sky charts out of that, which showed, the major mesosphere objects and some of the major NGC objects that I was trying to find. But Steve has said it, Phyllis has said it many times tonight. You really need to go and learn the constellations. And you can do that. There's actually an AL program. I don't want to plug, I am plugging the AL, but there is an AL program called Constellation Hunter. And I definitely say, get started on that, or do something like the,
You can even
Beyond
break it
Polaris.
down, Doug. You can break it down to learning the brightest stars first.
Right.
Yeah.
Right.
And then from there, you start learning that there are bright stars that are anchor points for constellations.
Right.
And that helps you perceive the constellations. And then you start referencing, like the Andromeda Galaxy, to its closest constellation.
Yeah.
And that, to be honest with you, I learned that using my LX 200. When I was in the star alignment, I had to have a bright star to align my scope, and that's how.
Where is Auriga anyway?
Yeah. I mean,
So
where's the big one for me? Arcturus. I had to learn. I had no idea what Arcturus was.
Yeah,
but I needed that as an alignment star when I first. I bought my LX90 telescope, and I needed Arcturus to align. I needed Polaris.
Right.
And I knew Polaris from surveying,
Right.
but I didn't know what Arcturus was.
Right.
Turn to find out it's a big ass bright star that's very, very easy to find. And I was like, oh my goodness, here I'm trying to find this thing and it's staring me right in the face. Yeah. And so that's how I started. And then I started learning the constellations.
Yeah,
Yeah.
there's there's in the back of the Mead manual, there's that very general set of guide star sky atlas there in the
Right,
back of the manual. And I started with that too. Because I'm just like you. I didn't know where Arcturus was. Didn't even
right.
know that there was such a star named Arcturus, or Aldebaran, or except from Star Wars, but that wasn't a star, it was a planet. But I mean,
That was Alderaan. Come on.
Oh, that's
Alderaan.
right. That's right. That was Alderon. Excuse me.
Okay,
Uh,
well,
So
let me
yeah,
answer this question with what I have in front of me. I've reached
can I?
over and
They have
grabbed
found it.
Sorry, Phyllis. Can I just jump in real quick? One of the things
Absolutely.
that I would say is with a planisphere,
Yeah,
you would first start out to make sure, if you know, well, the Andromeda galaxy, okay, where is it? It's in the constellation of Andromeda. You can then find where the constellation is at a particular time in at night, and where in the sky. So that would kind of give you a general area. And this will, again, this is kind of hard to see in there, but it's going to give you it will show you the outline of kind of what Andromeda looks like. And for me personally, I like to go off of the square of Pegasus, and you can see that in what Phyllis is showing you. It's basically, you kind of start, at least for me, my jumping off point was always that bright star Alpheratz, right off of the big square of Pegasus that then starts the constellation Andromeda.
this guy.
Yeah. So over to you,
Yeah,
Phyllis.
see, I
Sorry.
didn't like using Andromeda because it wasn't as easy a constellation to recognize. That's why I would always use Cassiopeia, and then I
Yeah,
would.
that's how I was taught the same way with Cassiopeia, the lazy W, and then just with the top part of the W, it's an arrow, basically the top part of the W that points about to Andromeda, and then you got to use about, then it's the old style using the, your hand motions if you don't have anything, or if you're using your, but it is a lot easier if you have somebody and you're sitting with them and showing them the sky. But the notion about the constellations, that's what they started us with. I'd taken courses many years ago, and that they had us literally memorizing the constellations to start with, and I think it's still apt. I think it still works.
I agree. There's just no getting around it.
Yeah.
And the good news is you can do it in your spare time. A lot of constellations have stars that aren't bright enough to see from your front yard. A few do, but a lot of them don't. So you may have to get away from city lights, but there's just no substitute for that. And back to Mike's point about the planisphere, if you take a planisphere or a magazine center chart and a pair of binoculars, you can learn a lot. And if you wanted to find the Andromeda galaxy, those are the two things that I would use. I would use either the chart out of a magazine or a planisphere, and I would use a pair of binoculars, and you'll see it.
Yeah. Oh, you'll definitely see it in a pair of binoculars.
I mean, I would argue what Doug was saying, learning the sky from the city limits where you have sky glow that's limiting your magnitude will make it much easier. You go out to somewhere like Staunton River and
Lost.
you're like treading water in an ocean. It's just unbelievable, all the stars you see.
You're
And
overwhelmed.
the constellations disappear. Yeah. So learning the sky from, I mean, it's a pro and a con learning the sky from using sky glow to limit your magnitude. It helps cut down on the noise so you see the brighter stars, but it also, you got to be careful not let that handicap you. You get into a really dark site, you'll lose those anchor points. So I mean, you really got to memorize Polaris, the North Star. Another one, the Summer Triangle. The Summer Triangle is not a constellation. It's just three very bright stars that create a triangle. And I can't remember, what is it? Vega, Rigel.
No, it's
Deneb.
Vega, Deneb, and Altair.
Altair. Yep, there you go. So those three stars create a triangle in the summertime, and it's obvious. You look up once someone points it out to you. it's easy to find. And then from there, you say, well, if I see the summer triangle, I know that there are a couple of different, like Cygnus the Swan is in there. You can kind of put it together in your head what is related to that big triangle, and it makes it easier.
Yep.
Okay, any more questions?
So I was going to offer, I've got my Stellarium open, and I have all my reticles set up, and I could actually go through a sample, Phyllis, if you wanted to, of kind of star hopping to get to Andromeda.
Go right ahead. That sounds fine.
Okay, all right. I will share my screen. If you might have to stop. Okay. Okay. All right, so here we go. So this is Stellarium. I'm going to just move forward a little bit in time.
Your Zoom UI is showing up. Can you disable that?
There we go.
There you
Much
go.
better.
Cool.
Okay. All right, so let's make this a little bit later in the evening. Okay, so I know that we're going to look for sorry, actually, I'm going to go back to normal time. I thought we were looking for Orion. Okay, so now we're let's see, we're now back at normal time. So if I go out into the kind of my southeast, and I can see, I know that Andromeda is right off of Pegasus, the horse. So this is the big square, or the great square of Pegasus that we were talking about. And then I know, okay, well, Andromeda is the Andromeda galaxy is over here. So if I had a Telrad, and so that's what my little Telrad looks like, and I would go off of, in this case, here's Alpharats. So what I'm going to do is I'm going to go off of the, in essence, I'm going to go from Alpharats down to this other star from Andromeda, and I could actually be, if I had a Telrad or my finder scope, I would be moving my telescope, kind of along this line. I could almost put Alpharats here, and then I know, okay, I got to move one more over, and then I would pick up this brighter star of Andromeda, keep going around. Now I've got to again get somewhat, oriented in the sky and keep going. So now I have to star hop down to Mirac, and I know that's going to be about 2.5 of my Telrads. So I'll go 1, 2, and then 3. So I see my, then I'll get to the star Mirac. Then I'm going to start moving my telescope up here towards the north. And I know I can actually kind of move that around in there. And I'm trying to find this, this other star right here. At that point, I can kind of move that Telrad around if I want to then say, okay, now I want to get my eyepieces. And so I apologize. I'm going to get that out. Is a nice wide field eyepiece. Why is this? Okay. All right, that turned me down to apologize. That moved me way down. Okay, so let me put my eyepiece in. Okay, so here I'm at that one particular star. I've got my widest field eyepiece in, so I know if I kind of start to go up a little bit, I will eventually start seeing Andromeda. So in this case, I've got a very long focal length telescope, so I can't even fit all of Andromeda into my eyepiece. But that's in essence how I would locate it. Once I'm fairly confident that my Telrad is sitting where I need it to be, Here's Mirak. My constellation labels back on.
Hey, Mike?
Describe what a Telrad is.
Yeah.
People don't know what Telrad is.
Yep, good question. I may just pull it up. And I apologize, I want to show that off. Picture's worth 1,000 words. So a Telrad is a finder scope that will, or it's a red dot finder. This thing will sit on top of your telescope. So some people may be familiar with ones that just display a tiny little dot. You may have a finder scope that's actually a mini telescope, so it has lenses. This actually is I think the easiest way to sum it up. It's like a it's almost like a heads-up display. And when you look through it, you wind up, you get these concentric circles. It's almost like, again, this heads up and these bullseyes. And no matter which way you look, it's corrected for parallax. So if you shift your head one way or the other, the reticles aren't going to move. So it allows you to, in essence, with like this bullseye, point your telescope. So it's nice and wide. You literally have this. On my scopes, I like to have them towards the front of the scope, and I kind of look back. So when I'm looking through my Schmidt-Cassegrain, I've got the Telrad almost way up by the dew shield, and I've got my head back down closer to the eyepiece, and I'm sighting along in essence, the barrel of the scope. So you could almost think of it as a gun sight on your telescope, and you've got these concentric circles. And what's perfect when you start using that Telrad is that no matter what, these circles, they're kind of, again, it's automatic. This is a 4-degree field of view. It's a 4-degree ring that you see in the sky, 2 and then a half a degree. So it makes moving your telescope much, much easier. In some cases, you might have a red dot finder, and the only thing it does, it doesn't display these reticles. It just displays a single dot. But again, if you know that your finder is aligned to the same on the same optical axis, and you basically see the same star in the very center of your eyepiece, as well as in the center of your red dot finder or your regular finder, your scope is pointed in the right direction. So to me, the Telrad is, for the money, it's not super expensive, but they are so worth every penny of it. It just makes life star hopping so much incredibly easier.
I mean, the fact that you're not looking through an eyepiece, you're actually looking at this thing attached to your telescope. You see a much bigger piece of the sky.
Yeah.
So you can actually see a whole lot more than just the Telrad reticle.
Yeah. If I was actually looking through my scope and sighting my scope, I'd probably have a field of view something like this. So I would be able to see Cassiopeia. So again, I might close one eye, but I'm not looking through an eyepiece. I'm literally just kind of staring up, across the top of my telescope, and I can kind of see this big, wide open area, and then these, concentric circles kind of floating in air. And it makes moving the telescope and aligning so much easier. So, if anyone has got a Dob and is, looking, is doing star hopping, I mean, to me, Telrads are the way to go. And
I think finder scopes are actually much harder to use than a Telrad. The Telrad gives you such a bigger view. Using a finder scope, you're really cutting down your field of view.
A powered finder scope. Yeah, I only use finder scopes, powered finder scopes, like a 9x50 or a right angle, 8x50 or whatever. I use that as a backup in case my Telrad's not working or it breaks or something. So
speaking of that, Mike, sometimes Telrads fog up. Yeah.
Yeah.
Yes.
Yeah, they
yes,
make dew straps that you can put on a Telrad.
Yes, I do use a dew strap, or actually it's a little element heater that goes in the window. It doesn't cover up the reticles, so you can still see everything. And I have a hood on mine as well. So
you have to make sure you turn them off. because otherwise, if you don't, if you have to put new batteries in every time.
Yes, yes, you do. So
So I've learned that many times.
yeah, so that's how I would, if I wanted to find the Andromeda Galaxy, that's how I've done it. And I think to Dave's point earlier, we were talking about the Cassiopeia. If you were to take kind of the more pronounced part of this lazy W, so kind of that more right angled, if you will, point. So in this case, it's from that star. I don't know what the proper shredder, for lack of proper pronunciation. You can kind of see it points over to the Andromeda Galaxy. So you would just have to know, okay, I'm gonna kind of just move my scope across the sky and towards the direction of the star Merak, and I should hit the Andromeda Galaxy.
I can talk real quick about a frustration that I had in the beginning. Aligning your finder scope to your main optical tube's field of view. That can be a really frustrating experience for a beginner. And a Telrad kind of gets rid of that. And what I'm talking about is when I would go out to set my telescope up, everything was disassembled. And I would set my mount up, then I'd put my optical tube on the mount, and I'd have to put my finder scope on the optical tube. And the process of mounting that finder scope would misalign it in relation to the actual optical tube. And so in the beginning, I would have to set up before the sun went down because I'd use the top of a tree or a radio tower or a building. I would use some object and I would look at it with my Schmidt-Cassegrain telescope, which has a lot of magnification, so a very narrow field of view. And then I would take my finder scope and align it to what I could see through the Schmidt-Cassegrain. And it was a really frustrating experience to try to do that. Whereas the Telrads, because it has such a wider field of view, it's easier to align.
Yep, absolutely.
And it's a give and take. The Telrad is not as accurate. It's rough. It's more granular. So you don't have the fine tuning that a finder scope gives you, but it's easier to use.
Absolutely.
Hey, a question on that Andromeda. Do you actually see that galaxy as like that picture?
No,
Absolutely not.
no.
Afraid not.
So I'm gonna put in. Let's see. I don't know. So this is through my refractor.
I don't know
My
if they still call it gray smudges. We called it gray smudges.
Faint fuzzy.
Faint fuzzy. So you won't see any of the color. You will, I think you'll definitely see, again, depending on how wide your field of view is, you can start to make out some of these, this, kind of that, the spiral nature of that, again, depending upon how good the conditions are. Probably not going to see that through my 4-inch refractor. But if I was on my, in this case, I would be looking through my basically my Schmidt-Cassegrain 11-inch. You can see even with my widest field of view, in this scenario, I've got a almost a full degree field of view, and even that Andromeda is filling it. But I'm not going to see all of this. I'm going to see kind of this really kind of I'll see the core, and then I'll see some structure, but you won't see color. It's not going to be that bright. You'll see kind of wisps of it. So, most of the time you're only going to see this really, really bright core.
It's Andromeda is 7 lunar diameters. So imagine the full moon stacked side by side 7 times. That's the width of Andromeda.
So the moon is this right here, this this first inner circle. And you can see to Steve's point, you start adding those across. I mean, just this, if you look at, here it's 2 degrees, this center one, and Andromeda is still kind of spilling outside of it. So, yeah, it's huge, but it's also incredibly dim when you talk about the edges.
Yeah, I don't think you could physically see the full 7 lunar diameters, but you could come close.
Yeah.
Everything that you see in the telescope is going to look a grayish green. And I never get it right. It's either rods or cones. I think the cones are the color sensor.
Color, yeah.
Rods
Cones C,
are the
color C.
brightness.
Yeah.
So we have a lot more rods than we have cones. And that's where averted vision comes in. The edges of your eyesight are predominantly rods, where the center is predominantly cones. So if you look away from the object slightly, you don't look straight at it, you look just to the side of it, but you kind of concentrate on what you see over here to the left, or I mean to the right or to the left, and you'll be able to see something you couldn't see if you look straight at it. That's what averted vision is.
Yep.
Phyllis, should I put up that list that I made on the chat? Is that, you think that's worthwhile? Can't hear
You're
you.
on mute.
You certainly can. You had some lunar charts there that we haven't even discussed tonight, so
Well,
please
okay.
share all that.
I'll just paste it all into the charts, all the links here if I can. Hang on.
I think that once the recording is done, the chat list can be duplicated.
Yeah, it can. I'll post the recording. Post the entire folder, and it will include the chat log.
All right, it's not letting me do it. I don't know why.
Share your screen.
It's not letting me put anything in the chat. I don't know why.
Oh.
You know what, Steve, I can email it to the group.
All right, yeah,
I'll
because
just do that.
for some reason it must be too long or something. It doesn't want to go in the chat. I mean,
How rude.
Can you upload it as a file?
hang on, let me just try a smaller version of it here. Maybe it's just too long for the chat. I don't know.
I have another question. Does anyone use an eye patch over the eye that's not looking through the eyepiece? I have that 10-inch Dobsonian loaner, and I'm finding that if I just do this, it's a whole lot more comfortable. And it's like that one eye through the eyepiece. It just there's no extraneous light coming in my this eye, that somehow tells my brain I'm seeing something else. So
I did it
seems like
primarily.
an eye patch would be
Yeah, I did it primarily for eye fatigue, because after a while sitting there as you're studying,
One eye, yeah, it gets tired.
yeah, you're just not feeling good. So I have the eye patch on, and I've got both eyes open, but one eye is obviously not seeing anything, and it makes it much more comfortable.
I would just put my cupped hand up to my eye if I was having a problem.
Yeah.
But
Yeah,
yeah,
I mean,
I've seen a lot of
Just a
people.
towel.
Yeah.
Yeah, there are a lot of things you can do, and I agree, it is helpful.
I've seen people that put like towels over their head, that once they get their night vision, they don't want it bothered, so they drape a towel over the end of their telescope over their head, and it just drapes down and it blocks any light that's around you, and it makes it a little bit easier to see what's in the eyepiece.
Yeah, as long as you don't have any blinking lights or anything on your mount, that's
Yeah.
you may want to put a piece of electrical tape on any lights there. But yeah, Rob, that's a really good point. It makes it much more comfortable to observe that way.
It helps in my neighborhood, because my neighbors, like their garage lights are on, and I found covering that eye really, really helps.
I put the list. These are books that I have of various charts and things like that. Some of them are incredibly detailed. So way more detailed than anything we've discussed tonight. If you want to know everything there is to know about something in a given constellation. some of these described them in great detail. And then there's lunar things here as well, in great detail also.
That's a good point. I was blown away by all the things that are up there that when you first start learning the night sky, you don't realize it's literally infinite. It's unbelievable. Just one constellation, what's inside that one constellation. You can spend the entire season just looking at one constellation.
Yeah. You can.
So, Steve, you posted the turn left at Orion. And again, I told you we got some great donations so far. And we also got, I believe this is not the most current version that was published. This might be version 5 or revision 5. Oh, sorry, it's the 4th edition, 3rd printing. So this is as of 2013, which is still phenomenal. So we will be also a door prize at an upcoming meeting. So attend meetings and get a option for some cool door prizes.
The Annals of the Deep Sky that I list here is actually in 8 volumes now, and they've only gotten through the C's of the constellations. So, and Sky and Telescope just purchased the publishers of that. So hopefully they'll continue on. We'll see. Because those are amazing.
Any other comments?